So last class we saw that if the variables and constants are lined up, so we have two equations, the x's are on top of each other, the y's are, and the constants, it can be pretty easy to solve if you add the variables cancel out, if they have the same number as the coefficient. And if they're the opposite signs, they cancel out right away. If you have the same number, but the same sign, like 4x and 4x, you can just multiply one equation by -1 to make it opposite and then add. But sometimes, like now, the coefficients aren't the same number. So we have 8 and -6, 14 and -7. So what do you notice about these equations? No coefficients are the same. So we can't add them, we can't use the multiply by -1 trick. However, we can multiply by other numbers. It doesn't have to be -1. So the easiest way to do this particular problem is if we look at the y's, there's something we can multiply the bottom equation by to make the coefficient the same and opposite. So think to yourself, what can we multiply -7 by to make it the same as 14? So you probably thought to yourself, oh, just 2. So we have to multiply everything in the bottom equation by 2. And I like to write it next to every number so that I don't forget to multiply something. So I'll write the new equation over here. So 2 times -6 is -12x. 2 times -7, -14y, and -20 as the constant term. And then we want to add the other equation to it, so let's rewrite it above. Alright, so now we're ready to add. So step 1, find the least common multiple of the variables you want to eliminate. So what the least common multiple is if you listed the multiples. So in other words, if we were looking at 7 and 14, I'll write LCM over here. So the multiples of 7 are 7, 14, and then if you add 7 again, 21, 28, and that's enough. 14, it's 14, 28, 42, etc., 56. Now there are two, out of these small lists that we made so far, there are two common multiples. So in both lists we see 14 and 14, and 28 and 28. But the least common, which is what the LCM stands for, least common, is the smallest, 14. So you have to think, what can I multiply the equations by to get 14 there, if we're looking at the y's. We could do the same thing for the x too, but this problem it's easier to do the y. Alright, so now let's go back to the problem. So we're adding 8x minus 12x would be -4x. And those y's cancel out when you add because they equal 0. 4 minus 20 is -16. So now let's divide by the coefficient, -4, and x equals 4. So step 2 was we multiplied the bottom equation by 2. Step 2, we added the equations together. And then finally, we solve for x, and now we have to solve for y. All right, so what we're gonna do now is just like when we do substitution, we're gonna plug our x value into one of the equations and solve for y. Now we could use either of the original equations, or we could even use the one that we multiplied to get. But I think because these are smaller numbers, I would use one of these. I'm just gonna choose the top one. So it's gonna be 8, and we're substituting 4 in for the x. So 8 times 4 plus 14y is equal to 4. So when we multiply, 8 times 4 is 32. Bring the rest of your equation down. And then it's just a two-step equation. So we move the constants to one side. And we're left with 14y equals negative 28. And I kind of ran out of room, but divide by 14. And y equals negative 2. All right, so we have our x and y. Just like graphing or substitution, you have to remember to write your answer as an ordered pair, x and y.